In this lesson, we're going to be studying the phases of matter, specifically solids, liquids, and gases. And this is our first lesson in Unit 5, the physical behavior of matter. We have a bookwork associated with this lesson, questions 1 through 6. You guys will do that in class, so please write this on the top of your classwork page. And also write this aim on the top of your classwork page. How do we describe the phases of matter? And just below that, on the classwork page, copy these do now questions, but don't answer them. We'll do that in class when I see you next. So this slide is going to cover some very basic ideas about solids. And my first question is, how do the particles within a solid move? The way the Regents describe the motion of particles of a solid is that they vibrate around fixed positions. So since they're vibrating around fixed positions, then particle A and particle B, for instance, although they would be in motion, they would never swap positions. So there are some characteristics of solids that you need to know. For instance, in your own words, what is a solid? Your whatever you write down may be different than what I would write down, but I would say that a solid is firm, it has its own shape, and it could be considered both hard or soft. But the chemical definition of solids is a bit different. The Regents will describe solids as having definite shape and definite volume. So that just means that if they have a definite shape, that they do not take the shape of their container. No matter what you place the solid in, it'll always have its own shape. And definite volume means that if you place it in a container of different sizes, that the size or the amount of space the solid takes up won't change. Now, relative to their phases of matter, solids actually have high order. And the order that we're talking about here is the regular geometric pattern in the structure of a solid. So here are some Regents questions about solids. What does it mean when the Regents say that solids have a definite volume and a definite shape? So when they say that, it just means that they do not take the shape or volume of their containers. So since solids are being held together in a regular geometric pattern, the reason for that is because they have extremely strong forces of attraction holding them together. A rigid, highly ordered structure is a term that you might use to describe solids. It also describes the word crystalline. And some examples of chemical substances that are solid at room temperature could be a substance like table salt, which you would indicate with an S inside parentheses, or even simply the metal iron, which you would have indicated as a solid with an S as well. So liquids have some similarities with solids, but they also have differences. The particles within a liquid are able to swap positions, meaning that they can move around within the substance. They are close together, just like the particles in a solid, but that they can flow freely. Especially in their ability to swap positions, this is a key difference between liquids and solids. So a liquid, in my own words, would be something that is fluid and takes the shape of its container. But the chemical definition of a liquid for the New York Regents is a bit more precise. They would say that liquids have a definite volume, but an indefinite shape. The definite volume part just means that if you have 30 milliliters of water in a skinny graduated cylinder, it'll rise to the 30 milliliter mark, and if you put it in a fat beaker, it'll still rise to the 30 milliliter mark, meaning the container that it's in has no effect on the volume of the liquid. However, the container that the liquid is in definitely does have an effect on the shape of the liquid. If you have water filling an ornate vase, the water will take the shape of the vase. But if the water is in a cube, then it'll take the shape of the cube. So those are the meanings for definite volume and indefinite shape. Comparative to other phases of matter, liquids, I would say, have a medium amount of order. And I would make that judgment based on the fact that the particles are close together, they're not spread out, but they can move past one another and swap positions. So it's not high order and it's not low order. Here are some questions about solids. What does it mean when I say that liquids have a definite volume and an indefinite shape? Substances that are liquids at room temperature actually would have medium forces of attraction. If they were strong, then they would be solid, and if they were weak, then they would be gas. The word that we would use to describe substances, of which glass is an example, that appear to be solid but whose particles are not arranged in an orderly pattern, that is one of the requirements for solids, is that they need to have that rigid, highly ordered structure. So if it looks solid but it doesn't have a rigid, highly ordered structure like glass, then we're going to call that an amorphous solid. So there are a few examples of chemical substances that are liquid at room temperature that you probably already know. H2O, of course, is liquid at room temperature. You use parentheses and an L to show that. But we also have a couple of elements that you need to know are liquid. Bromine is a liquid at room temperature, but also mercury is a liquid at room temperature. Take note that I included a subscript of 2 under the bromine to show that it's a diatomic molecule. Also, it's a nonmetal, not that it applies here, but just it's good to know, and mercury is an example of a metal that's liquid at room temperature. So for gases, the way that gases move is they move in random straight lines. And as they move in random straight lines, they are inevitably going to collide with the walls of their container and also with each other. And when they collide with the walls of their container, they exert a force on the walls of the container, and the force that they create is called pressure. So in my words, I would say that a gas is a collection of particles that are far away from one another, and they don't have a specific shape or volume. But the Regents would describe it as a substance that has an indefinite volume and an indefinite shape. And relative to other phases of matter, since gas particles are so spread out from one another and they're moving in such random motion, I would say that they have very low order. So some questions about gases. What does it mean when I say that gases have an indefinite volume and an indefinite shape? In short, it means that they take the shape and volume of whatever container they're placed in. Therefore, it should be pretty evident that gases at room temperature have weak forces of attraction holding them together. That's the reason why they spread out. And there is a special word that you need for vocabulary here. It's a word that is actually synonymous with gas. So it means the same thing gas means, but we use it when the gas that you're talking about is usually liquid at STP. For instance, water is usually liquid at STP, but you all know that clouds are water in their gaseous form. And in that case, instead of calling it a gas, we would call it a vapor. So some examples of chemical substances that are gases at room temperature would be anything that has low attraction for other molecules. So I always like to point out that it would be nonpolar molecules that would be likely to be gases. So some examples are molecules of oxygen, which are with nonpolar structures. And you also would have molecules of nitrogen with nonpolar structures, and carbon dioxide, which has a nonpolar structure. Those are just 3 examples, but almost every molecule with a nonpolar structure will be a gas at room temperature because of the low attractions they have for each other. So there's no pair up today, but I do want you to copy down these summary questions and even try to replicate this diagram. We will work on this summary in class tomorrow. Thanks for listening.